Hello guys! I am your teacher Lay,
I am your teacher, Maljoy.
and for today we will be tackling about the Hilbert's axiom. And under the Hilbert's axiom, there is the flaws in Euclid, the axiom of betweenness, axiom of congruence, axiom of continuity, and axiom of parallelism. But first, let us know who is Euclid and why is he connected into our topic. So, Euclid is the father of geometry, and he is best known for his works, The Elements. It is a comprehensive compilation of the mathematics known in his time, including geometry and number theory. And Euclid's Element is one of the most influential works in the history of mathematics and served as the main textbook for teaching mathematics for over 2,000 years. For the second one, let us know who is David Hilbert. So, David Hilbert was a highly influential German mathematician who lived from 1862 to 1943, and he made significant contribution to various areas of mathematics, including algebra, number theory, mathematical logic, and the foundation of geometry. And he sought to address flaws in Euclid and try to provide a more rigorous foundation in geometry. In simpler form, nung nakitaan niya ng parang mga kakulangan or kahinaan yung mga works ni Euclid, doon niya nasimulan or doon niya ginawa yung Hilbert's axiom. So let us move on into the flaws in Euclid. So for the first flaw in Euclid is the implicit assumption. And the works of Euclid lacks of formalization that can lead to ambiguity and difficulty in understanding the logical structure of Euclid's arguments. So in simpler form, the Euclid's axioms and postulates are not explicitly stated as such, rather they are assumed. So for the second flaw in Euclid is the parallel postulate. So it is the most controversial work of Euclid, diba? The fifth postulate, also known as the parallel postulate. So basahin ko lang, the parallel postulate states that if a line segment intersects two straight lines forming two interior angles on the same side that sum to less than the two right angles, then the two lines, if extended indefinitely, meet on that side on which the angles sum to less than two right angles, and this postulate is more complicated and less intuitive than the other axioms. So they spurred some advancement in mathematics, kaya naman they treat this as a flaw in Euclid and leading to the formation of non-Euclidean geometry. For the third flaw in Euclid is circular reasoning. So some of Euclid's proof rely on propositions that are proven later in the elements, leading to circular reasoning. And this can be seen as a weakness in the logical structure of Euclid's work. So fourth is the Euclidean bias. So Euclid's Elements is heavily focused on Euclidean geometry, which assumes a flat two-dimensional space obeying the parallel postulate. While this is a useful and applicable geometry in many cases, it is not only the possible geometry. So parang kinalimutan na natin yung mga other geometry like spherical and hyperbolic geometry, which have different properties and axioms. And for the fifth flaw is the geometric algebra. Euclid's approach to geometry is primarily based on geometric constructions and proof rather than algebraic methods. While this is effective for certain types of problems, it can be limiting in terms of expressing and solving geometric problems more generally. So parang nag-focus lang si Euclid sa mga geometric construction and proofs rather than solving in algebraic methods. So siguro gusto niya sa akin tanungin class, if, "Sir, why are we still studying the works of Euclid's? May mga flaws naman pala ito." So, keep in mind class that the works of Euclid remain significant for its foundational role on the development of geometry and its influence in mathematical thinking throughout history. And in addition, it gives foundation into the historical context of mathematics, and this allow us to understand more the um, principles and roles and reasoning. Let us move on to the Hilbert's axiom. So, Hilbert's axiom, ito yung naging sagot ni Hilbert sa mga flaws sa work ni Euclid. So, in definition, Hilbert's axiom refer to a set of foundational principles for geometry developed by the German mathematician Sir David Hilbert in the late 19th and early 20th centuries. And these axioms were an attempt to provide a rigorous and complete set of rules for geometry, particularly Euclidean geometry. And Hilbert's axiom typically cover basic concepts such as points, lines, planes, and the relationship between them. So for the first axiom is the axiom of betweenness. By definition, the axiom of betweenness is a fundamental concept in geometry, particularly in the study of Euclidean geometry. It is one of the basic axioms that defines the property of a line and the relationship between points on a line. And it also helps define the relative position of points on a line segment. Another, the axiom of betweenness states that for any three distinct points, points A, B, and C on a line, if B is between A and C, then B is also between C and A. In other words, the order of the points on the line is preserved, and regardless of which two points are considered. If B is between A and C, then B is also between C and A. This can be presented symbolically as B is between A and C, and B is also between C and A, where the symbol, the asterisk, represents the betweenness relationship. So, madali lang siyang intindihin guys. For example, may tatlong points sa line segment which is A, B, and C. So, titignan natin yung position and yung B is nasa gitna. So, it is between A and C, di ba? A, B, C. So, kahit baliktarin natin, yung C, ay kahit ipunta natin yung C dun sa pinakauna and yung A dun sa pinakadulo, ganun pa rin yon, nasa gitna pa rin yung B. So, yun ang axiom of betweenness. So, under the axiom of betweenness, there are three properties in it. So, the first is the betweenness axiom 1 or the collinearity and symmetrization. It states that if B is between A and C, then A, B, C are three distinct points all lying on the same line, and B is between C and A. So, dito sinasabi lang nila na kunwari may tatlong points ulit. A, B, and C. So, sinabi doon, if B is between A and C, ibig sabihin, there are three distinct points na nasa iisang line. Ano tawag natin doon? Collinearity. Or pag sinabi natin yon, they are collinear. And, ibig sabihin nun, if B is between A and C, it is also B is between C and A. Yun naman ang tinatawag na symmetrization. For the second property is the betweenness axiom 2, or we call this as the extension. Sabi dito, given two distinct points B and D on line L, there exist points A, C, E lying on line L such that B is between A and D, C is between B and D, and D is between B and E. So, titignan natin. So, meron tayong line segment dito, or tawagin natin itong line L. And sabi dito, there are two distinct points, the point B and point D. And sabi naman, there exist points A, C, E. So parang yung nasa picture sa line segment, there are 5 points, the A, B, C, D, E. And kung titignan natin, yung B, nasa gitna siya ng A and C. And yung C, nasa gitna ng B and D. And yung D, nasa gitna siya ng C and E. Pero nakikita rin natin dito na yung point D ay nasa gitna ng point B and point E. So, 5 points yung nandito sa line segment natin. Mahaba siya. And maraming betweenness ang makikita natin dito. Kaya naman ito tinawag na extension. And for the last property of axiom of betweenness is the uniqueness or the axiom tree. So let A, B, C be at 3 distinct points on a line. Then one and only one of the 3 points is between the other two. So consider natin there is a line, kunwari line L. And dun sa line L, may tatlo ulit tayong points. A, B, and C. Ang gusto lang sabihin nito ay iisang point lang ang pwedeng nasa gitna ng dalawang points. Ibig sabihin, kunwari, A, B, and C. Yung B ay nasa gitna ng A and C. Or yung B ay nasa gitna ng C and A. Ibig sabihin, doon sa tatlong points na yon, isa at isa lang ang pwedeng nasa gitna. Kaya sinabing unique or it is the uniqueness property. So, naintindihan po ba natin ang axiom of betweenness? So, if yes, let's move on to the axiom of congruence. By definition, the axiom of congruence states that if two geometric figures have the same size and shape, then they are said to be congruent. Congruent figures can be transformed into one another through a series of rigid motions, such as translations, rotations, and reflections, without altering their size and shape. So there are 3 properties under the axiom of congruence. First is the reflexivity, 2, symmetry, and the third is the transitivity. So when we say reflexivity, every geometric figure is congruent to itself. For example, triangle is congruent to triangle. Square is congruent to square. Circle is congruent to circle. And so on. For the second is the symmetry. If figure A is congruent to figure B, then figure B is also congruent to figure A. So for example, meron tayong dalawang triangle. Yung triangle A is congruent siya to triangle B. It means that the triangle B is also congruent to the triangle A. Yun po ang sinasabi nating symmetry. And for the last is the transitivity. If figure A is congruent to figure B, and figure B is congruent to figure C, then figure A is congruent to figure C. Paano naman po ito? Let's say that we have 3 rectangle. So rectangle A is congruent to rectangle B. And rectangle B is congruent to rectangle C. This only means that rectangle A is also congruent to rectangle C. Di ba sa mathematics tinatawag natin tong transitive property. Parang ganun lang din po ito sa geometry. Naintindihan po ba? Okay. So class, if tatanungin niyo naman ako, sir, what is the connection of the axioms, especially the axiom of betweenness and axiom of congruence sa flaws in Euclid? So the axiom of betweenness and axiom of congruence was affected by the parallel postulate's limitation, prompting mathematician to explore the non-Euclidean geometry. So ang naka-affect po dun is yung parallel postulate. So class, if naintindihan na po natin yung dalawang unang axiom, the axiom of betweenness and axiom of congruence. So Teacher Miljoy naman will explain the last two axioms, which is the axioms of continuity and axiom of parallelism.
So, we are done to the first two axioms of Hilbert, the axiom of betweenness and the axiom of congruence. And now, we are going to tackle the two remaining axioms, the axiom of continuity and the axiom of parallelism. So, axiom of continuity. The axiom of continuity asserts that a real number line is continuous, meaning that between any two real numbers, there exists an infinite number of other real numbers. And under axiom of continuity, we have the properties. So, property 1 is the density. The real numbers are densely packed on the number line, meaning that between any two real numbers, there exists an infinite number of other real numbers. So in density property, considering two real numbers, 0 and 1, between 0 and 1, or between these two real numbers, there exists an infinite number of other real numbers like 0.25, 0.5, 0.75, and so on. No matter how close these two real numbers, there will be another real numbers between them. So that is the density property. And the second property is the order property. The real numbers are ordered in a way that preserves their continuity, with every real number having a unique position on the number line. So, consider one or the positive 1 is on the right side of 0. That is 0. And negative 1 is on the left side of 0. Reflecting their magnitude and preserving the order. So this is the second property, the order property. So that is the order property. Do you understand? If so, guys, in addition, the axiom of continuity are needed to fill a number of gaps in Euclid's elements. Consider the argument Euclid gives to justify his very first proposition. So under axiom of continuity, Euclid gives he justify his very first proposition. So his first proposition is this: given any segment, there is an equilateral triangle having the given segment as one its side. So, ito yung first proposition ni Euclid. Given any segment, there is an equilateral triangle having the given segment as one of its sides. So, that is the first proposition of Euclid. So, sa first proposition ni Euclid, gumawa rin siya ng proof niya para i-prove yung kanyang first proposition. So, number 1. So, meron akong ginawa ditong illustration and i-base natin dito yung proof ni Euclid's. So, 1. Let AB be the given segment. Let AB be the given segment. With center A, radius AB. With center A, radius AB, let the circle BCD be described the postulate 3. And second, again, with center B and radius BA, let the circle ACE be described postulate 3. And next, from a point C in which the circles cut one another, draw the segments CA and CB. postulate 1. And next, since A is the center of the circle CDB, AC is congruent to AB by definition of a circle. Next, since B is the center of the circle CAE, BC is congruent to PA by definition of a circle again. And next, since CA and CB are each congruent to AB, they are congruent to each other by first common notation. And lastly, triangle ABC is an equilateral triangle by definition, having AB as one of its side. So ito yung naging proof ni Euclid sa kanyang first proposition. So this is the Euclid's proof sa kanyang first proposition. So under axiom of continuity, we have the principle. So our first principle is the circular continuity principle. So sabi dito, if a circle Y has one point inside and one point outside another circle Y prime, then the two circles intersect in 2 points. So sabi dito sa circular continuity principle, if a circle Y, so this is our circle Y, has one point inside the point A, and one point outside another circle Y prime, then the two circles intersect in 2 points, the point A and B. So that is the circular continuity principle. And next principle is the elementary continuity principle. So itong mga principle pala na ito is ginamit din ni Euclid para i-prove yung kanyang first proposition. So elementary continuity principle. So sabi dito, if one endpoint of a segment is inside a circle and the other outside, then the segment intersect the circle. So sabi niya, dito sa elementary continuity principle, if one endpoint of a segment, so if one endpoint of a segment is inside a circle, one endpoint of a segment is inside a circle, and the other is on the outside. Let's name this point as point A and point B. Then, the segment intersect the circle. So, let's name this circle as circle O. So, this is the elementary continuity principle. If one endpoint of a segment is inside a circle, and the other is on the outside, then the segment intersect the circle. So that is the elementary continuity principle. So our next axiom is the axiom of parallelism, and this is the last axiom of Hilbert'S. So, sinasabing itong axiom of parallelism is the most controversial among all. So, axiom of parallelism. The axiom of parallelism states that given a line and a point not on that line, there exists exactly one line through the point that is parallel to the given line. In other words, if a line intersects another line, and the interior angles on one side of the intersection sum to less than 2 right angles, then the two lines will intersect on that side. So, the axiom of parallelism. So it states that given a line and a point not on that line, there exists exactly one line through the point that is parallel to the given line. So let's name this line as line A, and this point is point P. So dito sa axiom of parallelism, sabi niya dito is, the axiom of parallelism states that given a line A and a point P not on the line A, there exists exactly one line through the point, one line that passing through to the point P. There exists one line through the point that is parallel to the given line. So let's name this line as line B. So this is our axiom of parallelism. So under axiom of parallelism, we have the properties. So our first property is the transversal property. Sabi dito, when a line intersects two or more other lines, it forms corresponding angles, alternate interior angles, alternate exterior angles, and same-side interior angles, all of which have specific properties when lines are parallel. So dito sa transversal, when a line intersect two or more lines, intersect two or more lines, it forms corresponding angles, alternate interior angles, and alternate exterior angles. So this is our transversal property. And our next property is the distance property. Parallel lines are equidistant from each other at all points, meaning that the perpendicular distance between them remains constant. So dito sa distance property, we have that. Let's name this as A and B. So sabi dito sa distance property, parallel lines are equidistant from each other. So meron silang distance to each other at all points, meaning that perpendicular distance between them remains constant. So parallel can never meet, and equidistant sila palagi. And meron silang distance. So that is distance property.
So before we end this lesson, I would like to share a quote from Euclid. He said that geometry is knowledge of the eternally existent. So once again, thank you for listening, and I hope that you learned a lot from us. See you next meeting.